This is the 9-1 to 9-4 review. Calculators still are not allowed, and it's number 4. In this case, we are matching slope fields to differential equations. So this is different than matching slope fields to the solutions. In this case, we have the slope of these little segments is going to be related to the location in the plane, and we'll need to know the x and y coordinates. So you can approach this one of two ways. One, you can either sketch the slope field that goes with these and then match them, or you can look at the actual slope fields and see if you can identify vertical slopes, horizontal slopes, and if you can see whether it's going to be in terms of x only or y only or both. So I'm going to do method 2, where I actually just analyze what's going on in the slope field. If I look in I guess it's Roman numeral 1, we can see that if I pick a particular x and move vertically, nothing happens to the slope. It stays the same the whole time. So that means that the slope in this plane depends solely on x. So x is only means it's going to be either the a or the d. So we can narrow that down in a minute. This one we can see, again, if we pick an x value, that the y does not impact the slope. So this one is also an x only. Here we can see that if I pick an x, the slope changes as I move horizontally. If I pick a y, the slope changes as I move, vertically and horizontally. So in this case, we're going to be in terms of both. Here we've got that same thing going on. I can't get the same slope vertically, nor do I get the same slope when I move horizontally. So this one is in terms of both variables. And this last one, I can see if I choose a y value and move horizontally, there is no change in the slope. So this one's going to depend on y only. So based on that, right away I can see that B is going to go with V, because that's the only one that is a y only. If I look at the two that are x onlys and narrow it down to a and d, well, here at a I can see that there's a problem at 0. So I would anticipate having some sort of an asymptotic behavior going on in the slope field. And I can see that here my slopes are getting steeper as I come either from the left or from the right. So I would say that A goes with Roman numeral 2. That means, by elimination, that this one is going to have to belong to D. If we double check, we can see that when x is a -1/2, I should get horizontal tangents. And we can kind of see that we're flattening out at this negative region, whatever it ends up being. And as we move to the right, that will become more and more positive. As we move to the left, it'll become more and more negative. We can also see that the solution to this would be a parabola, an x squared plus an x. And this is giving us a shape of a bunch of parabolas. So what we've done now is we've narrowed down to C and E. We need to fit those with these boths. So the first thing we can do is we can look for horizontal tangents. Here I've got a bunch of 0 little slopes here up along the line x equals 0. So if I plug in an x equals 0 here, I get a slope of 1, and I don't see a slope of 1 showing up everywhere. So that means C is not going to go with 3. However, if I plug in an x equals 0 here, I do get a 0 slope. So this one, 3, is going to go with E. Last but not least, by process of elimination, we can see that this one's going to go here. We can double check by letting x equals 0, we get a slope of 1. You can see all along this y-axis that I've got a slope of 1. Same thing if y is 0, that means all along the x-axis I got that same slope of 1. So it looks like this one is going to belong with 4.